Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I would like to discuss the question bank of Module 3, Partial Differential Equations, and it is in Part B, first video, and the subject is Differential Equations and Vector Calculus. So now I want to discuss some problems which are in the question bank and see the problem. In this we have the partial differential equation chapter. We have formation and we have the solution, that is Lagrange's equation. So the first problem is form a partial differential equation by eliminating the arbitrary constant a, b, c from the relation x square by a square plus y square by b square plus z square by c square is equal to 1. So first I write the given equation, the given x square by a square plus y square by b square plus z square by c square is equal to 1. Now our objective is to form the differential equation from this given function by eliminating the arbitrary constants a, b, c. For that, I differentiate the given equation number 1 with respect to x as well as with respect to y. First, on differentiating partially with respect to x. On differentiating partially with respect to x. So this is x term. So we will get 2x derivative by a square constant, and second term, it is pure constant when we are doing with respect to x. Y term treat as constant and b also constant. The entire term derivative is 0 plus 1 by c square and z square, because z is a function of xy. So we have to differentiate z square also, that is z square derivative 2z into dou z by dou x, that can be written as p is equal to 0. So on differentiating with respect to x, we will get 2x by a square plus 2zp by c square is equal to 0, and call this is equation number 2. Similarly, differentiate equation 1 with respect to y. So on differentiating, now on differentiating partially equation 1 with respect to y. So with respect to y means the first term will be 0. The first term x square by a square term will be 0, and y square by b square, that we will get 2y by b square plus 2z by c square into dou z by dou y, that is denoted by q. So 2z by c square into q is equal to 0. Or I can write it as 2y by b square, or you can cancel 2 also. So that the equation will be y by b square plus z q by c square is equal to 0, and call this is equation number 3. So here we can eliminate here also 2x by c square. 2 is not required. So on cancelling in the two equations, you will get x by a square plus zp by c square is equal to 0. So clearly here we cannot eliminate a, b, c from the equations 1, 2, 3. That means we need further one more equation. So it can be obtained by differentiating equation 2 partially with respect to x. So suppose if I differentiate, and again differentiating partially with respect to x, the equation number 2 we get. So on differentiating equation 2 is this is, and differentiating this with respect to x, we will get x by a square. we'll get 1 by a square plus 1 by c square constant, and here we'll get z into p. P is dou z by dou x, and z is also a function of xy. So we have to go for u into v method. So z means on differentiating. So we have to differentiate z into p with respect to x. Suppose if we put p is constant, then z differentiate with respect to x. That will be dou z by dou x. Dou z by dou x plus z treat as constant, and this is p differentiate dou square z by dou x square is equal to 0. So differentiating z into p in uv form. P is constant in the first term, z is derivative with respect to x, plus z is treating as constant term, and p means dou z by dou x, and differentiating with respect to x, you will get dou square z by dou x square. Or I can write this equation 1 by a square plus 1 by c square into p into p. Dou z by dou x means again it is a p. So p into p square, and z into, this is r. So r means, what is our notation? R means dou square z by dou x square. P means dou z by dou x. It is our notation. Throughout the chapter we follow. Q means dou z by dou y. So I can replace this by r. So z into r is equal to 0, and call this is equation number 4. Now what you have to do is you have to eliminate a, b, c from the equations 1, 2, 3, 4. Now I can use the equation 4 and equation 2. Equation 4 and equation 2. That means what I can do? Multiply equation 4 with x and subtract with the equation number 2. Now I am doing, now 4 equation 4 multiplied by x minus 4 equation 4 multiplied by x minus equation number 2. That is equal to, so what we will get? Equation 4 multiplied by x means x by a square plus x by c square into the 4 equation p square plus r into z minus, so what is equation 2? Equation 2 is x by a square, equation 2 is minus x by a square minus, what is the second term? Zp by c square. That also will get Zp by c square is equal to 0. So x by a square minus and plus terms will get cancelled, and 1 by c square on taking outside, you will get first term xp square, second term xrz minus z into p is equal to 0. So c square on writing right side, that will also 0. So the equation will be p square x plus x into r into z minus z into p is equal to 0, and clearly which is the eliminant of a comma b comma c. So there is no arbitrary constant a, b, c in the given equation. So which is the required, partial differential equation. So here we have formed the partial differential equation by eliminating the parameters a, b, c, and finally we got the eliminant of a, b, c, which is p square x plus x r z minus z into p is equal to 0. Here p means dou z by dou x, and zx, those terms are functions of x and z, and r is nothing but dou square z by dou x square. So already we have seen this model in the last video. Now we are solving in the another set of questions, in that we will get this one. Now see the second question. Solve the partial differential equation x square minus yz into p plus y square minus zx into q is equal to z square minus xy. So first you have to observe the given equation is in standard form of the Lagrange's equation or not. What is the Lagrange's equation standard form? Capital P into small p plus capital Q into small q is equal to R, where P, Q, R are functions of x, y, z. So here you can observe that this is P into small p, plus q into small q is equal to r. Solution. So the given equation is in the form of Lagrange's linear partial differential equation, capital P plus small p plus capital Q into small q is equal to R. Here small p is, this is same as dou z by dou x, small q means dou z by dou y. Here what is capital P? That is x square minus yz. And what is capital Q? Y square minus zx. And what is capital R? Z square minus xy. So clearly it is similar to the Lagrange's linear equation. So to solve the Lagrange's linear equation, first we have to consider the auxiliary equations. Now the auxiliary equations are dx by capital P is equal to dy by q is equal to dz by capital R. That is dx by, what is P? P is x square minus yz. Dx by x square minus yz, and dy by q term is equal to dz by r term. What is q here? Y square minus zx, and it is z square minus xy. This is called the auxiliary equations, and from this we have to find the two independent solutions. Thereafter we have to find the complete solution or general solution of the given differential equation. So from this we cannot, suppose if we consider the first two, we cannot get any solution directly. So I am using here I can write each ratio is equal to, I can write this as dx minus dy by x square minus yz minus y square plus zx. I am taking dx minus dy. Each ratio is equal to dx minus dy by this minus this. And also dy minus dz by y square minus zx minus z square plus xy. So how you will obtain this? You can easily observe that. And also dz minus dx. So the numerator subtraction dz by dz minus dx by the denominator subtraction, that is z square minus xy minus x square minus yz. Am I right? Here we can write, what we can write? Dx minus dy by, so this is first term, what is x square minus y square. Treat this as one set. Plus here z is common term. You can take z outside, then you will get x minus y. In the two terms on taking out z, you will get x minus y. Similarly, from the second term, what you can write? Dy minus dz by, here y square minus z square, and here xy minus zx. So x is the common term. So on taking out x, you will get y minus z. Similarly, you see the last term of the equation number 1, the above equation, here z square minus x square minus, what you can here, z square minus xy minus x square, this is plus yz. You can take y here, then you will get z minus x. In this term, you take y is common term, and taking out y, you will get z minus x. Now I can write dx minus dy by, what I can write? X square minus y square as x minus y into x plus y plus z into, what is the term? X minus y. Z into x minus y. In the similar way, you will get dy minus dz by, and this is, what is the term? Y square minus z square. That means y minus z into y plus z plus, and the term involved is x into y minus z. And the last term dz minus dx by, that is z square minus x square. So what I can write it as z minus x into z plus x plus, so what is the other term here? Y into z minus x. Just I am rewriting. So you can take x minus y is common term in the first term of the above equation. X minus y I can take outside. Then you will get common term is x plus y plus z. Similarly, in the second term of the above expression, dy minus dz, above equation, y minus z is common. Y minus z is a common factor. So what you will get? X plus y plus z again. And in the last term, dz minus dx by, here also z minus x is common. Z minus x is common. So on taking out, you will get x plus y plus z. So you can observe that all the three x plus y plus z is common. In all the three terms, I can take out, cancel out in all the terms. Then you will get d of, what you will get? D of x minus y by x minus y is equal to d of y minus z by y minus z is equal to d of z minus x by z minus x. And call this is another equation, equation number 2. Equation number 2. Now take the first two relations, then take the second two relations. From that you will get the two independent solutions. On taking first two, on taking first two, what will you get? D of x minus y by x minus y is equal to d of y minus z by y minus z. So on taking integration, on integrating, what will you get? Integral d of x minus y by x minus y is equal to integral d of y minus z by y minus z plus log c1 is the integrating constant. So it is looks like integral dx by x, integral d of x minus x. So this is the function. The derivative of the function will be in the numerator. That means what? Integral dx by x. So what you will get? This is log x minus y is equal to log y minus z plus log c1. I hope this is clear. Or I can write log x minus y by y minus z is equal to log c1. Log m minus log n, that is log m by n, that is equal to log c1. Or I can write it as, on taking out log both sides, you will get x minus y, therefore x minus y by y minus z is equal to c1. This is the first independent solution. Similarly, by considering the last two functions, what you will get? You will get y minus z by z minus x is equal to c2. This is the second relation. Therefore, the required solution, therefore what is the solution? Therefore, the solution will be in the form f of c1 comma c2 is equal to 0. That is function of, what is c1? The first relation. What is c1? You can see c1, x minus y by y minus z, x minus y by x minus y by y minus z, that is c1. Now y minus z by z minus x is equal to 0 is the required general solution of the given partial differential equation. So which is obtained by using the method of grouping and method of multipliers method. So here I have not multiplied anything. So just I make grouping by using the two relations taking aside, we will get the two independent solutions. On combined writing, we will get f of c1 into c1 comma c2 is equal to 0 is the required solution of the given differential equation. So this is the second problem. It is the formation of the partial differential equation. So solution, not formation. And problem 3 also, solve the partial differential equation p tan x plus q tan y is equal to tangent. It is very simple. It is also in the form p into capital P is equal to small q into capital Q is equal to R. So clearly it is Lagrange's linear equation. So what is P here? Here P is equal to small p into capital P. Capital P is tan x and capital Q is equal to tan y and capital R is equal to tan z. Then the auxiliary equations. What are auxiliary equations? Auxiliary equations are dx by p is equal to dy by q is equal to dz by r. That is dx by tan x is equal to dy by tan y is equal to dz by tan z. So clearly the relations, if you take 1 and 2, you'll get some solution because the solution is existing, because it is in variable separable form. You can find the solution easily. Similarly, you find the 2 and 3. You consider 2 and 3, you'll get another independent solution. So then you can write the complete solution or general solution of the given equation. Now, on taking first two. What are the first two? Dx by tan x is equal to dy by tan y. So on taking integration, what you will get? Integral 1 by tan x means cot x dx is equal to integral cot y dy plus log c1. So what is integral cot x? It is log sin x, and integral cot y, that is log sin y plus log c1. Or I can write it as log sin x by sin y is equal to log c1, or the solution is sin x by sin y is equal to c1. That is the first relation, first solution, first independent solution. Similarly, on taking last two, what you will get? Dy by tan y is equal to dz by tan z. So on taking integration, integral cot y dy is equal to integral cot z dz plus log c2. So integral cot y means it is log sin y, and right hand side log sin z plus log c2. Or I want to find out c1, like c1 it is c2 value. So log sin y minus log sin z, log m minus log n, that is log m by n. So I can write log sin y by sin z is equal to log c2. Or the solution on taking out log both sides, sin y by sin z is equal to c2, and call this is equation number 3. So we have obtained two independent solutions. One is sin x by sin y is equal to c1, and second one is sin y by sin z is equal to c2. Therefore, the general solution is given by capital F of C1 comma C2 is equal to 0. As per Lagrange's linear equation solution methodology, that is capital F of, what is C1? Sin x by sin y, comma, what is C2? Sin y by sin z is equal to 0. This is the required general solution of the given partial differential equation. And already we have observed that the equation is in Lagrange's linear form. So we consider the auxiliary equations. From that we consider the first two, and then we take last two. From the first two we will get the first independent solution. From last two we will get another independent solution. Then the final solution will be in the form f of c1 comma c2 is equal to 0. So which is the required general solution of the given partial differential equation. So these problems have been taken from the question bank of the course Differential Equations and Vector Calculus of the Regulations BT23 and published by IARE. So with these few problems, I conclude my lesson. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.